We're going to need to write balanced chemical equations for double replacement reactions, including predicting products and including going from the name to the formula. These are very common types of reactions. So starting with this first one, ammonium, I need to recognize that as a polyatomic ion. This is on your symbols to memorize chart. And then, so I'm writing it with its charge. Since that's a polyatomic ion, this is an ionic compound. So I write the ion's positive one first, put its charge there. Sulfide, I see the "ide." I know that's just the element, because if that were sulfate or sulfite, that would be a polyatomic ion, but it's just the element. And to get its charge, I look on the periodic table. And then I figure out if I need any subscripts to make this neutral. And on this one I do, because I have a +1 and -2. So I need 2 of the nitrates. I need to put that in parentheses to show that I have 2 of the whole thing. Copper, metal, this one's a polyatomic ion because it's 8. Remember, 8 and ite are polyatomic ions. Ide is going to be the element. So copper 1, we need to know that that 1 is a charge. So I put that there. And then nitrate, again, symbols to memorize, polyatomic ion. When I look at these, it's already neutral, +1, -1. So that is a good formula for copper 1 nitrate. Okay. Then when I go to get the products in double replacement reaction, what happens is that the positive part of one goes with the negative part of the other one. Always write these positive one first. The charge will be the same as it was before. And I don't need this is already neutral is what I'm trying to say, so I don't need to do anything with subscripts. So ammonium nitrate, and then again I'm going to use the positive part of this one to go with the negative part of that one. So I'm putting the copper 1 with the sulfide. Its charge did not change. Charges never change on a double replacement reaction. They stay the same. This one is not neutral. It looks like I need a 2 right there to make this a neutral compound. Now I'm going to show you something very important about predicting these products. Did you notice that I did not keep this 2? In other words, I didn't put parentheses around that and keep that 2. And the reason that I didn't keep that 2 is that's there from the charge. That is there because when I tried to make this neutral, I needed it to be there. It was basically because of this. Okay. But I did keep this 4. And the reason that I kept that 4 is that it's part of the polyatomic ion. So it is here as well. Same thing with this 3. I kept the 3 because it is part of the polyatomic ion, so I kept that. I could look at this 2. It wasn't there. It wasn't needed there. It's needed here. So if they're needed for the charge, they're there. And don't keep them if they're not needed for the charge. The last thing I'm going to do is balance this. And double replacement are pretty easy to balance. It doesn't matter where you start, it works out. Just there's a certain pattern you use. Also, double replacement are really easy to balance because you can balance the whole polyatomic ion. Notice that the polyatomic ions remain intact, the ammonium remains intact, the nitrate remains intact. And that makes it a lot easier because if I tried to balance nitrogen, I would have to look 3-4 places and keep it all straight. So anyway, I'm just going to balance ammonium groups. I have 2 ammoniums here and only 1 there. So I'll put a 2 here. And then I'm going to go to my other ion here. I have 2 nitrates, NO3s, 2 nitrates, and here I only have 1. So I'm going to put a 2 here. That gives me 2 coppers. See how I always go to the other ion, that this 2 just affected copper. 2 coppers, 2 coppers, 1 sulfide, 1 sulfide, and that's balanced.